This is probably the most straightforward way to create your own convolutional neural network. We are going to be creating a convolutional neural network with Keras in 3 simple steps. The first step is to load our dataset. If you haven't heard of MNIST so far, it's a dataset of handwritten digits. This dataset is good for beginners because it has a lot of tutorials all over the internet. In this dataset, you're given an image of a handwritten digit and your task is to classify it. To load our dataset, the first thing we need to do is load the basic libraries. NumPy is used to make matrices and vector calculations. Pandas we're going to be using to load and work with the dataset, and matplotlib to make some cool visualizations. And this time we're not going to be using pytorch, we're going to be using Keras. Keras is great to implement high-level neural networks, and this is exactly what we are going to be doing. Now you need to load our dataset into memory. We can use here the function pandas.read_csv and pass the train.csv file name. You can get those files at Kaggle. I'll be linking in the description below. Now that we have our dataset loaded, we can use matplotlib to make some visualizations. Here are some samples of our dataset. The second step is pre-processing. After loading our dataset, we can make some basic pre-processing, such as normalization. As we have just grayscaled image here, a simple way to normalize our dataset is to divide all pixels by 255. We also need to do some encoding. We're going to be using here one-hot encoding. Imagine that we have 2 as our digit. Our label for this image is also 2. As we have handwritten digits from 0 to 9, our labels are also going to be from 0 to 9. What one-hot encoding does is transform our label 2 into a one-dimensional vector that looks like this. We have a 1 in the position of our label, in this case 2. If we had a 9 instead of a 2, our one-dimensional vector would look like this. And for the final step, we are going to be creating our model. Now we have the basic setup to create our convolutional neural network. But first, we need to split the dataset into training and validation. Our test dataset is also provided by the Kaggle competition. We're going to be using here 19% into training and 10% into validation. We already have a training and testing dataset. You're probably asking yourself, why do I need another validation dataset? We use validation datasets to avoid overfitting our model. Using a validation dataset let us know when to stop training our model. If we look closely enough, we will see that our training loss will decrease as we train our model. But when we look at the validation loss, you can see in some time that the loss starts to increase. At this point, we know that we need to stop our training. Now it's time to create our convolutional neural network. If you are not familiar with CNNs, I'll be linking in the end of the video some useful resources. Keras make creating a CNN pretty straightforward. This just means that you can create your model just by passing a list of layers. And that's exactly what we're going to be doing right now. We can also add padding. In Keras there is a great option that is the same. The padding equals same here just means that we want our model to add as much as padding as needed, so our image input size doesn't change by the end of the layer. After we've created our first conv layer, we can create a pooling layer. We can use here the max pooling 2D. This just means that we are going to be downsampling our image by a factor of 2 on the height and width of our image. Now we can also add some dropout. This means that we are going to be dropping some inputs in the training phase. This is used to prevent that our model overfits our data. So in each epoch, we randomly drop some inputs. I'll be linking in the description some explanation in the Keras documentation of the pooling layer and the dropout. After this, we can add as much as layers as we can. In this tutorial, we're going to be creating another layer with 64 filters, the same pooling and the same dropout. Check if adding more filters can change your loss. Or you can change the kernel size, or you can add some more layers. You can play around here, but try to tackle one parameter at a time. Because for example, if you toggle with the pooling layer and the number of filters, you're not going to be knowing which one give you better results. And training CNN can take a lot of time, so play wisely. Now in the final layer, we need to flatten our vector so we can feed this to a dense layer, as we want final outcomes for our results. we just need to call the method flatten, and then we can move on to create our dense layer. One thing we need to do is to adjust the output of the final dense layer to the number of labels we have. In this case we have 10. Two last things we need to add here. Our optimizer. There's a lot of optimizers within Keras. Here we are going to be using the root mean square propagation. We are going to be using the categorical cross entropy as our loss function. We just need to compile the model now. Now we have our model set up. We can move on to the training and validation. With all of the previous steps, it's quite straightforward. And now we just call model.fit. We need to pass our training and label images, the batch size, the number of epochs, and the validation images and labels. I've explained these parameters in other video. I'll be linking in the card above. We've got 99% in accuracy in our training and validation dataset. And now if you want to use this model for the Kaggle competition, or if you want to draw digits yourself and fit to this model, we just need to call model.predict. But what can we do better here? One thing we could improve is data augmentation. I will let you practice to see how far you can get. Don't forget to subscribe, and I'll see you next week.